A rugby player passes the ball 7.00 meters across the field, where it's caught at the same height as it left his hand. At what angle was the ball thrown if its initial speed was 12.0 meters per second, assuming that the smaller of the two possible angles was used? Alright, so what are we given here? We are given the range, R, 7 meters, 7.00 meters. What else do we know? We know the initial velocity, the magnitude of the initial velocity. That's 12.0 meters per second. And what's A asking for? At what angle? Theta, which is the smaller angle actually. And we know that the range is given by initial velocity squared sine 2 theta, the angle, smaller angle generally, over the absolute value of the gravitational acceleration. So we have everything except the angle. So what do? Just rearrange the equation for theta. If you multiply both sides by the absolute value of gravitational acceleration and divide by the initial velocity squared, we'll get sine 2 theta equals to r times the gravitational acceleration divided by v naught squared. So this implies that sine 2 theta equals to r times the absolute value of the gravitational acceleration divided by v naught squared. Alright, so now 2 theta will be sine inverse of r times the absolute value of the gravitational acceleration divided by v naught squared. And therefore, if you divide both sides by 2, theta will be half sine inverse of r multiplied by the absolute value of the gravitational acceleration divided by the magnitude of the velocity squared. Plug in the numbers. Now remember, what we get here is a smaller angle. Theta sub s is going to be 1 over 2 sine inverse of r, which we are given to be 7 meters, times the gravitational acceleration in absolute value, 9.80 meters per second squared, divided by the magnitude of the velocity, which is given to be 12.0 meters per second squared. That will be the smaller angle. That's equal to 14.2 degrees. So the angle is 14.2 degrees. B. What other angle gives the same range? So theta L. Alright. And we know that complementary angles have the same range. And complementary angles are angles that add up to 90 degrees. Therefore, theta L, larger angle, will be 90 degrees minus 14.2 degrees. That's equal to 75.8 degrees. And why would it not be used? Because it takes longer time and also requires more energy. All right, and actually C will explain that. How long did this pass take? So time is required. C is asking for time. And we know that the range is equal to velocity in the x direction times the time. And this implies the time will be the range divided by v in the x direction, which is v naught cos theta. All right. If you use the smaller angle, the time it takes will be 7.00 meter over 12.0 meters per second multiplied by the cosine of 14.2 degrees. And that yields 0.602 seconds. So the time will be 0.602 seconds. If we were to use 78.5 degree, the cosine will be smaller and therefore t will be longer. And that's why we use the smaller angle instead.